Okay, let's continue. We just finished with accuracy, bias, and precision. Besides possible data measurement errors, there are also potential data collection errors. Incorrect data entry is one type of data collection error. So, if you input the wrong numbers when you're recording the data, it's obviously an error. Incorrectness refers to randomly introduced incorrect measurement results caused by human error or instrument error. For instance, the name John Smith may be recorded incorrectly as John Smith. When recording a piece of music, additional incorrect signals, for example background noise, may be recorded together with the correct sound signals. Other types of data collection error include unnecessary data duplicates. You might have duplicates that weren't supposed to be there, and inconsistent data entries. These incorrect data are also known as noise. Okay, so we talk about incorrect data as noise. Okay, attribute domain types and operations. The domain of an attribute is just the set of permitted values for that attribute. So the domain of a variable is just the set of permitted values. So if you're talking about favorite soda for a person, what their favorite soda is, you wouldn't include in that like names of cars, right? Those would not be the domain of that attribute. If you're talking about temperature, you wouldn't include colors, right? You would only include numbers. In fact, in the context of data analysis, the domain of an attribute is characterized as nominal, ordinal, interval, or ratio. So if we talk about soda preference, that's nominal. If we talk about temperature, that's going to be, depending on which scale we use, it's going to be either interval or ratio. We'll see that in a minute. Nominal. Values of a nominal domain are distinct names. Among the names, no concept of order or difference of any kind exists. So, what we mean by that is, like, if you're talking about soda preference, like Coke, Pepsi, Sprite, and so on, there's no order there. It's not like you have like hot, cold, or medium. There's an order. Even though those are kind of names, there's a kind of order there, right? Hot, medium, cold, there's a kind of order there. But here, when we're talking about nominal data, for example, soda names, there's no order. So we won't call it ordinal. So what can you do with those kinds of data? Like if you have numerical data, you can add it, you can divide it, you can subtract it, and so on. But it doesn't make sense to do that with soda names. You can't add soda names. The only sensible operations that can be applied are comparing two nominal names from the same domain. For instance, a nominal attribute country, so you might have a variable called country, may have Britain, France, and China as its values. Both Britain and Britain makes sense. What's that supposed to mean? Sorry. Sorry, it's both Britain equals Britain and Britain does not equal China. Makes sense. But Britain is greater than Britain and France is something Britain do not make sense. Okay, so you can't do these kinds of numerical operations. Sometimes a less rigid operation, such as match or agree, can replace the equal operator. In food appreciation, good and nice may be considered as agree in the meaning, although the two words are literally different. However, this operator may differ from application to application. In word processing, for instance, even Smith and Smith may not be considered as equals, so it depends on how you're using it. Okay, the next kind of data we want to talk about is what's called ordinal, after nominal, ordinal. Values in an ordinal domain are also names. There exists a certain order, however, among the names, but any difference between the names is not defined. What does that mean? The differences don't make sense, but there is an order. Let's see, for example, cold, warm, or hot. Cold, warm, or hot. So these are names, but there is an order, as I said earlier. Cold is, we can say, less than, warm is less than hot. However, you can't do any kind of division here, or subtraction, or addition, but there is an order. So in general, all comparison operators, such as greater than, less than, I don't know what that means, whatever, are applicable in an ordinal domain. For instance, a day may be described as cold, warm, or hot, and there is a general belief that cold is colder than warm and warm is colder than hot. But how much colder that cold is than warm is not known, and the result of warm minus cold cannot be defined. Okay, the next type of data after nominal and ordinal is interval. And now interval, you can talk about differences. You can subtract. Okay, interval domains contain numeric values. Interval quantities are measured in fixed and equal units. Both concepts of order and difference exist among the values. Therefore, how much bigger one value is than another can be defined. All operations applicable to ordinal domains are also applicable to interval domains. Some arithmetic operations, such as addition and subtraction, can also be applied. However, an interval data type has no definition of an absolute zero, and arithmetic operators, such as multiplication and division, cannot be applied. For instance, let's see an example of this. The calendar year of birth is an interval attribute. If John is born in 1978 and Susan in 1980, we can calculate that John's year of birth is 2 years earlier than Susan's. However, we can't say that 1980 is sort of, what do I want to say? We can't take the ratio of 1980 to 1978 and have that have any particular meaning. Okay, finally we have what are called, or another example is another example of interval is when you measure temperature in Celsius or centigrade. So for example, we say that water freezes at 0 and water boils at 100. So if, for example, we say the temperature is 22 today and it was 11 5 weeks ago, we don't say that the temperature, we can say that it's 11, that the difference between today and 5 weeks ago is 11 degrees, so differences make sense. But we don't say that the temperature is twice as hot today as it was 5 weeks ago, right? We wouldn't say that. Okay? So that's because we don't have, that's because 0 doesn't represent the absence of whatever it is that we're trying to measure. So so 0 doesn't mean that there's no temperature. Okay, on the other hand, if we use the Kelvin scale, where 0 is minus 273 in centigrade, then that 0 does have a meaning. It does mean the absence of something. It means the absence of all energy. So I can say that, for example, 50 degrees Kelvin is twice as hot as 25 degrees Kelvin. Okay? So that's the difference between, that's what we mean by ratio data, interval data versus ratio. Ratio is Kelvin. Interval is centigrade. So ratio quantities are similar to intervals, but they have an absolute 0 point. For ratio domains, all arithmetic operators and comparison operators are applicable. So when we're doing data mining, we have to think about what can we do with this data? Can we add it? Can we multiply it? And so on. And if we have to be careful on the operations that we use on it, and we have to think about the kind of data that it is. For instance, the distance between two places on a map is of ratio type. The distance from a place to itself is considered to be 0. The distance from London to Birmingham is longer than the distance from Oxford to Cambridge. The distance between London and Glasgow is more than twice the distance between London and Birmingham. The 0 point is inherent in the sense that it is related to knowledge and culture. The Fahrenheit temperature measured does not have an absolute 0 point. So Fahrenheit doesn't, also Celsius and Celsius or centigrade don't, as we said before. However, Kelvin has an absolute 0 point. Okay? With a given data set, one should not just take the data as they are presented. Okay, so you can't just consider data just it looks like a number, so treat it, as interval data. You can't do that. You have to be careful. So it's common practice in a database, for example, to define the data type for a user ID attribute as a long integer. So a lot of times in a database you'll have the user ID, and you'll use an integer to express the user ID. However, these integers are labels used for convenience, not for arithmetic operations, such as addition and multiplication. Even comparing whether one user identifier is smaller than another makes little sense. Often nominal and ordinal types are called qualitative types, nominal and ordinal, and interval and ratio types are called quantitative types. Nominal and ordinal types are also known as categorical, so we can call them qualitative or categorical. Whereas interval and ratio types are known as numeric types. So I'll use those words. Actually, I'll use categorical mostly, but also sometimes nominal, and also sometimes qualitative. A domain with enumerable values is discrete. That means countable values is discrete. But if we talk about all the real numbers between 0 and 1, those are not considered to be countable, and so we're going to call that a continuous domain. Okay.